Okay, for today, I'm gonna teach you about dynamic ions. So dynamic ions has two, that is monoatomic ions and also polyatomic ions. Okay, for monoatomic ion is for anion, that is non-metal, and also polyatomic ions is for cation metal. For the monoatomic ion, add I to the element name based on what element you've been given, determine it. So example, chlorine equals to chlorine negative, that is chlorine to chloride. Okay, for polyatomic ions is add I or A to the element name based on the charges of the element. For example, Ca, that is calcium, and NO nitrate. Okay, you see the charges are 3 and 2. Okay, for NO3 it is for calcium nitrate, and then calcium nitrate for charges that has 2. Okay, okay, for the sample question is, okay, see, sodium nitrate. Okay, because it is metal plus with non-metal. For magnesium it is NO3. For nitrate and also NO2, the magnesium nitrate. Okay, magnesium nitrate. Okay, okay, next is the relative atomic mass, RAM, the weighted average of all of the naturally according to isotope or the element. RAM formula percentage, you multiply it with mass number plus the percentage multiplied by mass number, and then you divide it by 100. Okay, for the simple question, okay, you have the bracket 69 multiply 60 plus the bracket 31 multiply 65 divided by 100, then you get 61.55. Okay, for the next question we have 99 98, and then you divide it, then you get 1.000143. Okay, for mole, for the mole is the amount of substance that contains as many elementary entities as there are atoms in exactly 12 or 0 grams of 12C. Sample question is calculate the number of moles in 10 gram of um, sodium chloride. Okay, you use the formula M over MR, that is 10, you divide it with 58.5, so 0.171 mole. Okay, for the next topic is molar mass. Molar mass has two, that is mass and the number of atom molecular ion. For each of it, there's formula. So for the mass moles, you multiply it by RMM and also or RAM. Okay, for moles you multiply it by Na. Okay, so the second question is, you divide it, and M divided by MR, then 6.46 divided by 4.0. Okay, you get it 1.615 mole. So the other question is a simple question, M over AR 12.3 divided by 7, you get it 1.757 mole. For B, and multiply NA 1.757 multiplied by 6.02 multiplied by 10 to 3, and then you get the answer is 1.00 multiplied 1024 atoms. Okay,
Formula mass.
What is formula mass? Formula mass is the sum of the atomic mass of all atoms in a chemical formula. It tells you the total mass of one formula unit of a compound expressed in atomic mass unit AMU. First, we need to write the chemical formula. Second, look up the atomic mass of each element from the periodic table. Third, we need to multiply each atomic mass by the number of atoms of that element in the formula. And fourth, add them all together.
Empirical formula.
So, what is empirical formula? The empirical formula of a compound is the simplest whole number ratio of atoms of each element present in that compound. It does not show the actual number of atoms in a molecule, but rather the lowest ratio between them. So, first, obtain the percent composition of each element from experiment or given data. Second, we need to convert the percentage to gram. Assume 100 gram of the compound. And third, we need to convert grams to moles using atomic mass. And the next step, we need to divide all mole values by the smallest number of moles to get a ratio. And last step, we need to write the empirical using the ratio.
Molecular formula.
So, what is molecular formula? The molecular formula of a compound shows the actual number of atoms of each element present in a single molecule. Unlike the empirical formula, which give only the simple ratio, the molecular formula tells you the true composition of the molecule. Alright, first step, we need to find the empirical formula, simplest ratio of atoms. Second, we need to calculate the empirical formula mass, sum of atomic mass in the empirical formula. Third, divide the compound's molar mass by the empirical formula mass. And last step, multiply the subscript in the empirical formula by this whole number.
Naming hydro acids.
So, how to naming hydro acid? First, we need to start with the prefix hydro. Second, add the root of the non-metal element. Third, add the suffix IC. And fourth, finish with the word acid.
Naming oxoacids.
What is oxyacid? Oxyacid is an acid that contains hydrogen, oxygen, and another element. So right now, how to naming oxyacid and oxyanion. Rules for naming oxyacid. First, we need to identify the polyatomic ion. Second, check the suffix of the ion name. Third, add prefix if needed. And fourth, write the full acid name by combining the modified root with acid. So, rules for naming oxyanion. First, we need to identify the central atom. Second, we need to count the number of oxygen atoms attached to it. Third, apply the prefix if needed. Fourth, combine root, prefix, suffix to form the name.
I will explain how to name molecular compounds. First, molecular compounds are formed when nonmetals combine with other nonmetals or nonmetals combine with metalloid. To name molecular compound, we use this Greek prefix. This prefix will tell us how many atoms for each element are present in the compound. For example, mono means 1, di means 2, tri means 3, and so on. Okay. Now, the first element keeps its original name, but the second element always ends up with "ite". Okay, we usually do not put mono for the first element. For example, we look at Hi. Hi has hydrogen and iodine. Like I said, the second element always ends with "I", meanwhile the first one stays its original name. For the second one, this is nitrogen and fluorine. Okay, for fluorine, we have 3 atoms, so we put tri in front and "I" in the back. Same goes as sulfur oxide. It becomes sulfur dioxide. Percent composition means the percentage by mass of each element in a compound. In this question, it gives 12.04 gram sample of liquid compound that contains carbon, hydrogen, and nitrogen. The masses of each element are 7.34 of carbon, 1.85 of hydrogen, and 2.85 of nitrogen. To find percent composition, we use this formula: N times molar mass of element divided by molar mass of compound times 100. Okay, to find carbon, 7.34 gram, we divide by 12.04 times 100 and then we got 21.0%. Hydrogen, 1.85 gram, divide by 12.04 gram times 100 and then we got 15.4%. Nitrogen, 22.85 gram, divide by 12.04 gram times 100 and then we got 23.7%. Okay, how to find stoichiometry calculation? First, we find the number of moles of methanols. It already gives 205 grams of mass, and then we divide by molar mass, 22 gram per mole, and then we get 6.5313 mole of CH2OH. Then we use the mole ratio from the balance equation. Then we got 2 mole of C4H10, 4 mole CO2, then 6.5313 divided by 2 times 4, then we have 13.0625 mole. Okay, last, we convert moles of water to mass. 13.0625 mole times 18, then we got 235.125 of H2O produced.
So, what is limiting reactant? the reactant in a chemical reaction that limits the amount of product that can be formed and thoroughly consumed during a chemical reaction. Excess reagent is the reactant in a chemical reaction that remains when a reaction stops when the limiting reactant is completely consumed. The excess reactant remains because there is nothing with which it can react. For question 1, determine the limiting reactant. We need to make a table. Reactant, we need to write NH3 and O2. To find mole, we need to use mass divided by molar mass. So 2 gram divided by 17 gram per mole equal to 0.1176 mole. For O2, mass divided by molar mass, 4 gram divided by 32 gram per mole equal to 0.1250 mole. And then divide with coefficient. 0.1176 mole divided by 4 equal to 0.0294, and then for O2, 0.1250 divided by 5 equal to 0.0250. So conclusion, excess reactant reagent for NH3 and O2 is limiting reagent because mole for O2 smaller than NH3. So for question 2, find the mass of NO produced. First, ratio from the equation, 5 mole O2, 4 mole NO. Find the mole of NO produced. So we write down 5 mole O2 produced 4 mole NO. 0.1250 mole O2 equal to 0.1250 mole divided by 5 multiply 4. How we get this? We get from the equation. Equal to 0.1000 mole of NO. And then mass of NO produced, mole multiply molar mass, 0.1000 mole multiply 30 gram per mole equal to 3 grams. Question 3. Find the mass of excess reactant remains after the reaction has stopped. Ratio from equation, we write 5 mole O2 and 4 mole NH3. Find the mole of excess reactant of NH3. 5 mole O2 produce 4 mole NH3. 0.1250 mole O2 equal to 0.1250 mole divided by 5 multiplied by 4 equal to 0.1000 mole of NH3 reactant. And then find the mole of excess reagent remain of NH3. So formula is mole of excess reagent available minus mole of excess reagent reactant. So 0.1176 mole minus 0.1000 mole equal to 0.0176 mole. So find the mole of excess reagent. Find the mole of excess reagent remain NH3. So formula is mole multiply molar mass. So 0.0176 mole multiply 70 gram per mole equal to 0.2992 gram. Reaction yield. To find reaction yield, we need to use formula actual yield divided by theoretical yield multiply 100. So we use formula actual yield divided by theoretical yield multiply 100. So 0.77 gram multiply 100 divided by 0.80 gram. So the answer is 96.25%. So molarity. To find molarity, we need to use formula moles of solute divided by liter of solutions. Unit for molarity is mole divided by L, or we can use M. First, we need to find mole. To find mole, we need to use formula mass divided by molar mass. 5.84 gram divided by 58.44 gram per mole equal to 0.100 mole. To find molarity, we need to use formula mole divided by liter of solutions. So 0.100 mole divided by 0.500 L equal to 0.200 M. So hydrate ionic compound. Hydrate ionic compound has specific number of water molecule attached to them. The number of water molecule is shown after a dot and is named by Greek numeric prefix before the word hydrate. So for example, barium chloride 2H2O. So barium chloride 2 we just write down, and then after dot we have 2. So 2 is D, and then H2O we write as hydrate. And then lithium chloride dot H2O, lithium chloride we just write down lithium chloride, and then after that we have 1. 1 is mono, and then H2O we write as hydrate.